In this video, we're going to work through the problems that deal with working back and forth between sigma or summation notation. So in our first series, we're given it in expanded form, and we're asked to write the series using sigma notation. We should notice that it goes on forever, and we're not going down by the same amount. It's down by 10, then 9, a decimal, so it's not arithmetic. My other option would be that it's geometric, basically because that's the other one I know the formula for. So if I'm looking for an R, I can do 90 divided by 100, and I get 0.9. And now I should check that that works for the other terms. So 90 times 0.9 gives me 81. Good. And if I take 81 times 0.9, I get 72.9. So that is looking good. So we now know that this is geometric, and R equals 0.9. We also know our formula for geometric is a sub n equals a sub 1 times r to the n minus 1. So now we're ready to write it in sigma notation. There's sigma. I'm going to start with n at 1 for the first term. It goes on forever, so it's going to go on to infinity. A sub 1, I'm going to use this formula here, is 100, my first term. My r is 0.9, and I put n minus 1 there, and I'm done with part A. In part B, I'm asked to find the sum of the series, and no, we're not asking you to add these terms till infinity, but we do notice it is an infinite geometric. We should also notice that R, thankfully, is between -1 and 1, which means we can use this formula, a sub 1 over 1 minus r. This formula is given to you, you just need to know when to use it. Our first term is 100. We already found r was 0.9. And that gives us 100 over 0.1, which is 1,000. All right, in our next problem here, we were given our problem in sigma notation, and we need to write the first four terms. So those first four terms occur when n equals 1, n equals 2, n equals 3, and n equals 4. So when, or actually in this case, I should work with I since that's what's in our summation notation. All right, so when I equals 1, I get 3 to the negative third, or 1 over 27, because it's 1 over 3 cubed. When I is 2, I get 3 to the negative 2, or 1/9. When I is 3, I get 3 to the negative 1, or 1/3. And when I is 4, I get 3 to the 0, which is 1. And then, of course, this is going to go on for a while. Next, I'm asked to calculate the sum of the series. Now, hopefully we recognize that this was a geometric series. One way we can recognize it is we can see that we have an exponent and 3 under the exponent, or we can just look at these terms and see that we're multiplying by 3. So this is geometric. R equals 3. It's not infinite, and also r would have to be between -1 and 1 to use the sum for infinite. So we need that other sum formula, which is this one. It's given to you. You just need to recognize when to use it. So here's our sum formula, and we're finding the sum of 15 terms. So sum of 15 terms. I know my first term, it's 1 over 27. I know my r, it's 3. N is 15 all over 1 minus 3. And now it's about putting it in our calculator correctly. So here we go. We've got 1 divided by 27 as our first term. And then we've got 1 minus 3 to the 15th divided by, and make sure the bottom's in parentheses or you subtracted it in your head. Divided by parentheses 1 minus 3, press return. There's our answer. I'm going to drag this over so I don't have to remember the number. 265,720, and it said, I didn't say how to round, but I'm going to round to, I guess, the places given to me on the calculator. So there we go. There's my sum of 15 terms. All right, our last problem here asks us to write this in sigma notation. And I look at this and I'm like, okay, I'm adding 4. Oh yeah, I'm adding 4 each term. All right, so this is arithmetic. Arithmetic has the formula in this form, a sub 1 plus d n minus 1. So I go here and I'm like, okay, I'm starting with my first term, but I'm not sure how many terms there are. I'm going to come back to that. I know that my formula starts at -8. I'm adding 4 times 4 for each term. So there's my formula. And all I need now is this number at the top. I can actually use this formula to figure it out. I'm going to figure out which term is 400. So I put 400 on this side. My first term is negative 8, d is 4, and if I solve this equation, I can find n. So here we go. I'm going to add 8. 408 equals 4n minus 1. I'm going to divide by 4. So 102 equals n minus 1. Add 1, 103. So there we go. I have 103 terms up there.